Okay, so we're going to look at another class. We're going to look at a simple bank account class. Before doing that, I just want to review what we just looked at in the number utils test program and mention that you might be thinking about one of the criticisms of unit testing, and that is that it's lots and lots of code to test less code. So you'll probably write, 3 to 5 times the amount of code that you'll need to test something, right? So if a method, is 5 lines long, you might end up writing 3 to 5 three-line methods to test that, right? And that is a criticism of it. But the benefits of it still really hold. It's this idea of formalizing and documenting and preserving these test cases that can both document how you expect your program to run and also make sure it still runs in the future if changes are made. All of those benefits still hold. The other thing is that you'll notice that, again, this unit testing does not test how your code integrates or works with other aspects of your system, right? But it's not designed to. It's really just meant to test this one individual unit. In our case, the one class, two methods that just the one method, rather. We didn't even test the is-odd. We just tested is-even. That one method that we were looking at, you would want to create more tests to test the is-odd method, right? So those were all just for the is-even. But that's all it's designed to do. It's not meant to do that larger testing. It's meant to just isolate one piece or one unit of your program and test that unit. And the idea is that at the end, you are confident that that part, that one individual part in isolation, works the way it's supposed to. And the idea would be that if you are aware, if you have that confidence in every part of your program individually, each individual component, that then once you put them together, then you can think about how they all function together. But it is important to first know that they all function properly on their own. Okay. Now, the other thing is that, this isn't infallible because, of course, it depends on you choosing the right test cases, right? So it's still, unit testing is still written by humans. It still requires humans to be thoughtful about what code to test. So it isn't a perfect system, right? Because, again, it's still programmed by a person. And we can still make mistakes in our test program just as well as we could in our regular code, right? So it's not infallible, but again, it is a step towards sort of formalizing and putting some structure around the testing process. So let's keep that in mind as we look at our next class, bank account. So here I have a simple bank account class. I just have a balance that I send to my constructor. I have a deposit method that just takes in a parameter for the amount. If that amount is greater than 0, it adds it to the balance. I have a withdrawal method that takes in an amount, and if that amount is greater than 0 and less than or equal to the balance, it subtracts it from the balance, and then I just have a getter for balance. So again, pretty simple method. And we're going to write a unit test to test the deposit and the withdrawal. Some unit tests for deposit and withdrawal. So here's my test class. Again, it's called bank account test, and I've got all my imports here for JUnit 5 and for the Jupyter package. Now, what I'm going to do is I'm going to use a bank account instance data variable. So this is an instance data variable. It's declared outside of any method. I'm going to use that to test my methods. Now, the previous example we looked at, we were just testing static methods. We didn't need to create an object. For this test, we do need an object because we need something to invoke, deposit, and withdraw on. And then I have some constants here I'm just going to use too. I'm going to use an initial balance of $100, and this is going to be my threshold that I've set for comparing doubles. So you'll notice here in this class, in addition to my test methods that we'll go through, I also have a method that I've tagged as before each. So this is typically called setup, and this is a method that's going to run before every single test method. So the idea here is that this is code that you want to happen repeatedly once before each test method runs. And in our case, what we're going to do in this method is we're going to create or initialize that bank account object. The idea is that I want to create a new object every time I run a test case, because I don't want the results of a previous test case to have changed the object and then that influencing my new test case. So I want to run each test case or test method with a brand new object. So I've tagged this as before each. That means I'm going to invoke this code, or execute this code rather, one time before every single one of these test methods is run. So let's look at our test methods. Actually, before we do that, what I encourage you to do is pause the video and think about what test cases you think you should run to test the deposit and withdrawal method. So think about what are the kind of breadth and range of test cases that you think you need to run to feel confident in those methods. Okay, and again, keeping in mind these are simple methods, right? But you can kind of envision how this would work for more complex ones. So I'm going to test that a positive amount that you deposit increases the balance. I'm going to test that if we deposit a negative amount, it leaves the balance unchanged. And I'm going to test that if we deposit zero, it also leaves the balance unchanged. So I'm going to test my deposit method with a positive, a negative, and a zero. I didn't choose to test with an even, an odd, or a prime, or composite because that doesn't really have any relation to what this code does, but positives and negatives are involved in the code. So that's why I want to check a negative, a positive, and zero. And then similarly, I want to check that if I withdraw a value less than the balance, or sorry, withdraw a negative amount, that leaves the balance unchanged. If I withdraw a positive amount up to that balance, it should decrease the balance. If I withdraw zero, it should leave the balance unchanged. So again, I want to withdraw a positive, a negative, and zero. But there's one other test case I want for withdraw. I also want to test that if I withdraw that balance, that the balance goes to zero. So if I have $150 in my account and I withdraw $150, my balance should be zero. So that's a border case. So I want to check that border case to make sure that it works correctly. So anytime, again, you have methods with this kind of a thing, a conditional, you want to check your border. So you want to check just on the other side of this, which would be, a negative number. You want to check the border, which is a zero. You want to check the balance, and you want to check on either side of the balance. So anytime you have those kind of ranges, you want to check around those endpoints. So here I'm going to check that if I withdraw the balance, again, it changes to zero. And I'm also going to check that, hey, if I withdraw more than in the balance, it should also leave my balance unchanged. So here I have kind of 5 ranges, right? I have negative, I have a valid withdrawal, kind of zero between the balance, and then I have the end point, which is the full balance, and then I have more than the balance. So actually, is that, 4, no, 5, right? Yeah. Oh, because I included zero. So yeah, kind of 4 ranges of values that I'm testing. Now, what I did in this program is I put in some print lines. The purpose of these print lines is just to show you how this before each method works. In general, we don't typically include print lines in the unit testing methods because, again, the purpose of the unit testing framework is that it provides you the information you need to track things down. A lot of times we use print lines to debug things manually, but if we're using JUnit testing or any kind of unit testing, we don't need to do that. So the purpose of these print lines, again, is just to show you how things are running. So all I've done is I've just put a print line that shows which method I'm in because I just want you to see the trace of how this runs. So for example, in my deposit positive increases balance method, so again, this is how I like to name my unit tests, just saying that what am I doing? I'm depositing a positive number, and what should the action be? It increases the result be? It increases the balance. So going back to our kind of little template to think about, we want to create the variables, invoke the method, gather the result, and make our assertion. So we already know we have an account variable because that happened in our setup method. So now I want to create my value, or my variable rather, for my positive deposit. So I'm going to use 50, for example. Now I'll figure out what is the balance before. And again, this should always just be 100, but just to be on the safe side, I'm going to obtain the balance. I'm then going to deposit that value, and then I'm going to figure out what my after balance is. So what was the balance before the deposit? What is the balance after the deposit? Now, then I'm going to make my assertion. I'm going to assert that the expected result is before the balance plus the value, that should be the result I'm expecting, is equal to the after balance within this threshold. These numbers are doubles, so I am going to use that threshold to account for precision. So again, what I'm saying here is I'm asserting that the expected value is equal to the actual value. And if that is true, then this test case will pass. And if it's not, I will see it flagged when I run it. So similarly here, I have a negative value. And now I'm asserting that the before balance and the after balance will be equal to each other, right? So I'm asserting that the balance won't change. Same thing for if I deposit zero. Withdrawal, similarly, if I have a negative, I'm assuming that the leaves us unchanged. Yeah, so that I changed my, maybe try to be consistent, sorry about that. So here, I'm asserting that my before and after balance is equal because the withdrawal of the negative should leave it unchanged. Withdrawing a positive up to that amount. So for example, $50, if I withdraw that, I'm asserting that the before balance minus that value is going to be equal to the after balance. So it was correctly subtracted. If I withdraw zero, If I withdraw 0, it should be unchanged. If I withdraw the full balance, then my after balance should be equal to 0. Okay, so I'm asserting that the after balance is 0. If I withdraw more than the balance, I'm asserting that, again, there's no change. Okay, so that's all of my test cases. So let's go ahead and run this. And first of all, you'll notice in the output what's happening with that setup method. So it's in the setup, and then it's in the test withdraw more than the balance. It's in the setup, and then it's in the deposit of positive. It's in setup, and then it's in the test of deposit of negative. So two things to notice here. One is that there's no guarantee the order at which these tests will be run. So that's another reason why it's really critical to make sure that each test is an independent test case meant to test a very specific and narrow situation. You can't have test methods dependent on each other because there's no guarantee of the order in which they're going to execute. And then the other thing to notice, again, is this setup method. Because we tagged it as before each, it will be executed before each one of our tests. If this was before all, which does not make sense for this particular test, but just to show you what that looks like, it would happen once, and then we fail. Well, we're going to fail because I actually get an error. Oh, because it's not static. So before all methods have to be static. But if then we have to make this static. Okay, so if we run that, you'll see that the setup code happens just once. Okay, so again, you got to think about whether you want the code to happen each time you run a method, or if you want it to just happen one time. So I'm going to comment these out because, again, their purpose was just to kind of show you those two things about the order of the methods and what order they're run in. It's not the order you write them in. And also to just emphasize that setup method, because it's tagged as before each, it happens before every single test is run. So there's our unit testing for bank account. Now let's go in and introduce a bug and see what it looks like. So let's say, for example, that in our withdrawal method, instead of saying that if the amount was greater than 0 and less than or equal to the balance, let's say less than the balance. Let's say we just made a mistake. We left off the equal sign. Okay, so let's say we didn't catch that mistake. We think our code is good to go. When we go over and run our test cases, we'll see we have 8 test cases and 1 failure. So when we look at that 1 failure, first of all, our method name is helpful. It says withdraw balance changes the balance to 0. And here we can see on our little failure trace, it says, we expected 0, but we got 100. So we can go to that method and we can say, okay, well, this was supposed to withdraw the balance. It was supposed to be 0, but it was actually 100, meaning it wasn't changed at all. Let me go in and look at why. And hopefully that, again, would track down this place where the error is and say, okay, well, something is wrong in the withdrawal method when I try to withdraw the full balance. Why is that? Well, if I go to withdraw the full balance, this if condition fails, and so I never execute this code. And hopefully that would, okay, that's where my bug is. All right, so again, the idea is that if you choose your test cases carefully and you have a broad range of test cases that covers the full breadth of all the situations you need to account for, that hopefully will help you track down any errors that you have. Okay, so we're going to look at one more example before talking about parameterized tests.